This week we're going to be covering correlations. A correlation is used in an effort to try and describe a relationship between two variables. So for example, if you are asking is height significantly correlated to weight, what you're asking here is there a relationship between height and weight? You could also say, is there a relationship between the number of guns a person owns and their income? So here the number of guns and income are our two relationships that we're looking to see if they are related. And this question specifically asks for a relationship, which is nice. Or is sugar intake related to levels of attention? So sugar intake and attention here are our two variables. Now a correlation leads us to a value called the correlation coefficient. In the PSPP output, they'll refer to this as the R value, or the Pearson's R. And correlation coefficients range from -1 to +1. The nice thing about these numbers is that they tell us two things about the relationship that we're looking at, the strength and the direction of the relationship. We can tell about the strength of the relationship, is this a strong or a weak relationship, by looking at the actual value. So if the value is close to either +1 or -1, that would be a stronger correlation. A value that's closer to 0 is a weaker correlation. So for example, if we look on this number line, we can see that to the far left and to the far right are the places where our strongest correlations exist, and then numbers that are into the center towards 0 are weak correlations. The actual sign of the correlation has nothing to do with the strength. That tells us something about the direction, which we'll learn about in a moment. In the real world, a significant relationship or a significant correlation coefficient would be in the 0.2s to the 0.3s. You might be thinking to yourself, well, you should be in a 0.7 or a 0.8 to have a strong relationship. And that is true, but unfortunately, when you're studying something really complex, such as human behavior, it's very challenging to get a relationship that big. One of the largest natural relationships would be between height and weight, and that's correlated at 0.8. But when it comes to things like emotions and attitudes, you have a harder time finding those strong correlations. So a 0.2 or a 0.3 is something that you as a researcher would get excited about. So a couple of examples here. The amount of time a person spends in traffic and their good mood score is correlated at about -0.6. -0.6 is quite a strong relationship because it's close to the -1 value. The number of roommates a person has in their loneliness score is correlated at about -0.3, which is a moderately sized relationship and in the real world would be exciting. The number of hamburgers you eat and the score on your math test is correlated at a 0, which means that there is no relationship. Watching violence on TV and later aggressive behavior is actually correlated at +0.3, and in the real world this again is a substantial correlation. And then, as I said, height and weight is correlated about 0.8. So the numbers that are closer to -1 and +1 are stronger. The numbers that are closer to 0 indicate a weaker or no relationship. Now, in terms of the direction of the relationship, this is where you look at the actual sign. So if the value of your correlation coefficient is positive, you would have a positive correlation. And what that means is that as one variable goes up, the other variable also goes up. Or as one variable goes down, the other variable also goes down. So in this graph, we can see, and this is called a scatter plot, we can see that they're looking at the height and the arm span of individuals to see if there's a relationship. And this is a positive correlation because as you are taller, you tend to have a larger or longer arm span. A negative correlation is when one variable goes up while the other goes down, or vice versa. So here we're looking at the hours per week of television watching and GPA. So the more hours per week someone watches TV, the poorer their GPA becomes. So it might be tempting here to say, oh, so watching TV causes you to have a bad GPA. But remember that in the realm of correlation, we can't use the term causation. So correlation does not mean causation. These numbers are meant simply to describe a relationship, not talk about which variable is causing the other variable. Those are questions that are better answered with things such as t-tests and ANOVAs that we've talked about before.